speaker is Shantanu Dutt, the Senior Architect and Technology Evangelist at Amazon. He is responsible for educating companies with service offerings of the AWS platform, as well as helping them in their architecture with their best practices to build highly scalable and resilient applications on the AWS cloud. Shantanu has also been a regular speaker at premier industry-wide conferences like NASSCOM, E-Tailing, Infocom, CIO Club TIE, Cloud Connect, among others, and evangelizing on technologies like cloud computing and big data. So, can you please put your hands together to welcome Shantanu Dutt to the podium.
Good morning, everyone.
Good morning.
Wow, that's cold response. Good morning. Good morning. That's more like it. I know I'm standing between you and the beer, but then just bear with me for the next 20 minutes. I was asked to talk about something interesting or something cool, and I decided that just to kind of, it's Saturday, to make the session a bit lighter, rather than talking about the business side of Amazon and Amazon Web Services, which I'm happy to talk about during Q&A or after the session offline. I'll just take you through some fun use cases which have seen growth in a significant manner via companies which were very small or startups, started many years ago, globally or in India, and then significantly grown because of the internet space and the cloud. Right? We've seen that it's a vicious cycle between innovation and scale. Right? People say that you innovate at scale simply because you kind of reach economies of scale which allow you to innovate, and then when you are at scale, innovation becomes easy. Right? And that's what I'm going to talk about a little bit. Just a quick question. How many of you have shopped from Amazon.com or Amazon.com? Most of you. The ones who haven't raised their hands, we should chat over this session as to why. I'm just joking. So Amazon.com, obviously, as you all know, started off 20 years ago as an e-tailing slash e-commerce store, online selling books, and then obviously has grown into what you know today as the various entities inside that organization, including AWS, which is cloud computing. Right? Unlike the perception that AWS is an excess capacity, just excess capacity that Amazon.com might have, which is extended into kind of end users for them to use. It was an independent entity right from day one, back in 2006, which is about 9.5 years ago. It was a project taken up internally within Amazon.com when Jeff Bezos wanted an efficient way of web services calls to kind of consume internally. And so Amazon.com or parts of Amazon.com started using AWS. And today, Amazon.com, the way we treat them is almost like a customer, right? A lot of parts of Amazon.com run on AWS, be it the credit card transaction, billing, some parts of the website, and so on and so forth. And on Amazon Web Services, what we have seen is a significant growth of startups, as I was mentioning a little while earlier, who have grown to a stage where really, if you look at some of their tenets there, in terms of the growth, the scale, their revenues, or the way they stand in terms of the valuation, they really can't be called startups anymore. Right? They still operate like startups, but they aren't really startups. Some of these names have become household names. So what we'll do is, for the rest part of the presentation, look at some of these key customers of ours. Most of them are customers. Interesting use cases and some scales that they've achieved, which some of you may or may not know about. And then a little later, we look at the Internet of Things and how that's kind of evolving with the cloud as well. Right? Talking about sharing and collaboration, or storing, the concept was always there, but Dropbox took it to the next level. Everyone obviously here is aware of Dropbox. I have this interesting conversation or argument with some of my customers and some of my colleagues that is Dropbox an enterprise application or is it a consumer application? Well, if you actually think about it, the answer is it's both, right? Because it is used by enterprises for their official documents, etc. now, for collaboration across geos and regions and offices, as well as for the end consumer. What some of you may not know is that Dropbox has a significant scale which is achieved recently. As of, I think, a few months ago, I'm sure this figure has increased, they had 300+ million users registered and actively using their application worldwide. Every day, over a period of 24 hours, they save about 1.2 billion files uploaded into Dropbox from across the world. It goes into cloud storage back in Amazon. So we kind of, when we work with such customers, learn a lot about their use case, and we kind of, it kind of rubs on, and it's a vicious cycle where Because of the scale, our scales underlying increase, and then because of that, it kind of feeds into our learning, and then it kind of works both ways. Talking about Angry Birds, everyone here is aware of Angry Birds. One of the key tenets of the cloud in general, and this is very, very underrated, is the cost of failure. Right? People talk about innovation and how disruptive it can be, but the key piece to innovation is you have to lower the cost of failure. Because if you lower the cost of failure, you can try again and again and again, not have any liabilities, and then innovation becomes a little less liable in terms of what your cost of failures could be. Angry Birds, for those who don't know, the form and shape that you see Angry Birds as of today, from the mobile game or otherwise, this was actually made successfully as the current status it is on the 52nd attempt, which means that 51 times Angry Birds was tried to kind of form into something, and the founders failed. Right? Just imagine the cost of failure if they were to do it the traditional way or in a traditional data center. Right? It's going to be huge because you just can't spin up resources at this, toss of a coin, because it can be difficult. Netflix, how many of you have heard of Netflix? Most of you, right? The online streaming movie and TV serial company in the US. They started off in the traditional sense, shipping DVDs to US homes many years ago, and they realized the power of internet in America, which is obviously a no-brainer, given that every middle-class apartment has 100 Mbps fiber optic cable terminating, or the equivalent. Netflix started off with online streaming of movies and TV serials. They decided that given their unpredictable scale, they did the use case on the cloud. And today they've grown to a scale which is enormous, to the point where on an average weekend, a US weekend, that is a Friday evening to a Sunday evening, 25% of the entire United States internet bandwidth is consumed by Netflix. Which brings me to the question as to what is the productivity of some of the Americans there. They're just watching movies or shopping on Amazon.com, right? But that's besides the point. But that's what they have become in terms of just streaming content. They get into big data analytics big time. They get into kind of details of which movie or which video or which TV serial was not only viewed how many times or played how many times, but which part of it was kind of the most popular, right? Suppose there are kids taking a slider bar here and watching it between, let's say, the 8th minute to the 11th minute repeatedly. They kind of go there, have that in the log files and find out as to what is there in that portion of the movie which makes it popular for a certain age group, based on which they kind of go back, buy more rights for similar kind of content, and then kind of take that. Animoto, I'm not sure so many of you have heard of it. It's for some reason not really known in parts of Asia. What these guys started off was really small but cool back in the days, which is if you actually have family pictures or videos or music, etc., you kind of upload it to Animoto. You then give it a theme and select some cool features, and what it will do is it will create a video for you. You have a premium model, so you can go back home and try it. But these guys were small and relatively unknown before they launched a Facebook app. Right? And then it kind of went viral, right? Because friends started connecting friends. And then so much so that at one point in time, right, sorry for the font, I'm sure you guys from back can't see, but this arrow there at the bottom is when they launched the Facebook, and without them knowing, they kind of expanded from running 50 servers on the cloud, because back then they were very small, to 5,000 servers within a matter of 72 hours. I think it was April 2009 or 2010, I don't remember clearly, but somewhere there within a period of 72 hours, they grew 100x without them even knowing, because they kind of were provisioned for scaling out horizontally. The architecture was in place, and some of them didn't know this was happening till they realized midway through those 17 hours that this is actually scale. And there was no impact outages or anything that they knew about. After which it kind of plateaued and then went down and then went ahead. 1000 Genomes Project is an interesting project. This is a project by global data scientists around the world to collect DNA sequencing samples from, I think it's 14 different ethnic groups based out of Central America, Africa, and parts of Asia. Just imagine the kind of data or the data explosion that might come in this case, right? We have something called a simple storage service or simple distributed service, which is super simple in terms of just presenting it to public users. And then we kind of have taken all this data, which runs into hundreds of terabytes, close to a few petabytes, and given it up for free for download, right? Because it's at the economies of scales that we have had because of such customers, and we're privileged to have such customers. It comes to a very, very low cost for us to store this. And then this is going to be used by data scientists around the world to kind of find cures and patterns for diseases like cancer or otherwise, which are specific to certain regions and why those are there. Somewhere a few years back when this was happening, right, all these huge customers coming on us, or customers coming in a small time and then becoming big, we kind of were faced with an interesting challenge of building our data centers across the regions. Because obviously you need to have some amount of buffer capacity given how quickly some of these customers can ramp up. And at the same time, you really can't have too much buffer capacity because then your own capex or kind of your business might be there. And so what we decided was to come up with this interesting concept of spot instances, which is extremely unique, which is whatever buffer capacity that Amazon Web Services has, that is free capacity, we put it up for bidding, like literally. And so when you have workloads like batch processes, test workloads, you want to try something for a couple of hours, do big data analytics which will last for 3 or 4 hours, you can actually launch or choose spot instances which actually come to you at 90% lesser the cost versus the dedicated capacity, because if you actually bid for a price which is higher than the market price, just like a stock market, that instance of the server becomes yours for the next 1 hour. If the market capacity by any chance goes above that because someone else is bidding higher, and that instance will be taken away from you without any warnings. Scary but interesting proposition where some customers have kind of built their business models on this. You can't obviously do it in production database servers, but there are many use cases like batch processing or big data analytics where customers are using this. On the same concept, we took some of the spot instances and kind of on-demand instances, and back in 2011 created a supercomputer for us, right? Just for scientific analysis, for internally for Amazon, and then kind of expose this for public reference. And whoever thought that a supercomputer would be built back in the days, which would be costing you for a few dollars per hour, right? So we built a 17,024 cores, CPU cores, that is, supercomputer, some crazy amount of RAM, and it cost us $6,800 per hour. The instance types aren't mentioned, but it was a specific type of family that we used. And then I think a year later, the cost went down because obviously given our volumes increase, our cost of compute that we procure from our suppliers goes down. And then the cost reduced by about $1,300 later. And then we kind of, shut down the supercomputer in a matter of minutes because we didn't require it. Schrodinger, a company based out of, I believe, Portland, Oregon, is a company into digital data science, pharma space, etc., where they kind of analyze DNA sequencing and help do that with active molecules. When we actually went to them, or my counterparts in the US, and we spoke to them, what we realized was sometimes we as people, as human beings, seem to be constrained by the constraints of IT or the environment that we work in. Because we asked them, how many molecules do you process per day? And they said about 8 to 10, maybe 12. And we asked them, what would it take for you to process thousands of molecules each day? And they literally said, there was a data scientist sitting next door, and he actually ran up his calculations on a computer and said, it would either take about $12 million or, he said either it will take millions and millions of dollars or 12.5 years to do this, right? Literally, because that is the way they did processing. And so some of our architects went in there and helped them design this with spot instances and on-demand instances. And today, they actually do thousands of active molecules at about $3,500 an hour by launching a 50,000 core supercomputer-like farm of instances. Shut it down after 3 hours. So that's about $3,500, that's about $10,500 per hour of paying Amazon for the processing. But they end up doing about 100x or 150x the times of processing that they used to do a few days before. And as a result of that, their bottom lines and the business has obviously drastically increased and given them more flexibility to kind of scale up. And then they do this about 5 to 6 days in a week for those 3 hours, and for the remaining 21 hours, they are shut. Coming back home, closer to home, Shaadi.com has kind of decided to take this to the next level. How many of you have had arranged marriages? Come on, it's okay. Okay, I haven't, but okay. If you have used any of the marriage portals, this is kind of taking it to the next level. They kind of use some of our big data analytics engine, literally, to kind of take these scores of matchmaking to a different level and have additional metrics of matchmaking to to kind of build a recommendation engine, right? So they already had a basic recommendation engine saying that this person belonged to the so-and-so community at this age group could like or be a good fit for this person of the opposite sex. This kind of takes it to a further level to kind of go deep into more data points based on history. And so we have a saying that big data can find out. We have a lot of Indian-based ad-serving companies or ad exchanges, online ad serving, which are becoming extremely popular for us, given their use cases, which is infinitely really scalable and in an unpredictable manner, and our platform, which kind of complement each other. There's this company which kind of changed the name, and I couldn't disclose the name. I was told this morning, so I just written as very large ad exchange based in the West region in India. I just can't name them right now. I can name them in a few days from now. Those guys are huge, right? And so are some of the other guys. To give you examples, they kind of work in an ad exchange where they work with publishers and advertisers who kind of buy and collaborate on their exchange to kind of meet. And then exchange bids on what the bid price of an advertising will be and run ad campaigns online. And they work at a scale which is decent, even at the size of Amazon that we see other customers running. To give you an example, some of these, the one that I can name now, generates about 500 to 550 GB of data every hour. Okay? This is 7 days a week, 550 GB of data every hour. On a daily basis, they serve about 17 billion ad impressions, and they have not yet reached their peaks, which is Christmas and New Year. Typically, they kind of scale out very, very easily, run into 1500, 1700, 1800 servers / spot instances or on-demand instances on the cloud. And then at night, depending on the region that you're serving the ad, when it's the low non-peak periods, go down to about 200 or 150 instances. Simply. Etsy, this is an interesting example as well. Now, the e-commerce market worldwide is booming, right? And there's a way that every e-commerce company does things. Etsy is a little different. What Etsy does is sells online handmade ethnic goods. The challenge with handmade goods or ethnic goods is every item or product is slightly different from the other. And so as a result, what you can do in an e-commerce site, which is productized categories, electronics, computer accessories, fashion apparel, and so on and so forth, you can't do that with these sites, right? And so they decided to solve this problem by kind of running a taste test, right? Which is whenever you go to Etsy and take the taste test, it actually shows up 5 or 6 pictures on your screen. And based on your preferences or your likings, you just choose the right pictures. And then those pictures will be stored as a part of your profile, and a profile will be made for you. Now, that is very useful for someone like me who tends to forget his wife's birthday every few years. I can actually go to my wife's Facebook profile, go to the taste test, find out what gift to give her, get a reminder, and know what gift to give her because based on liking. And they actually run a lot of big data analytics behind the scenes on the cloud for this, so that they kind of get preferences and future preferences of their customers or their end users. When we're talking about the cloud, we have this saying that the possibilities are limitless, and the use cases that we saw up until now were obviously restricted to the planet Earth as we know it, right? One of our most exciting, this is my personal favorite, use cases on the cloud is from NASA. Right? NASA launched a robot called as the Curiosity robot 2.5 years ago for their Mars mission. I had this fancy idea because I happen to keep some interest in astrophysics, that this robot will be controlled by some joystick by a data scientist sitting in their JPL laboratory in the US. Completely unknown. One of the data scientists who used to work at NASA now works for us, and I actually had a good chat with him back in Seattle a few months ago, where he kind of explained this entire procedure. What this Curiosity robot does is has a camera fitted at different locations inside its body and goes around the planet of Mars taking pictures. Now, because NASA has spent billions of dollars sending this robot, and it has an end life, it has a shelf life, every time the robot stays idle, NASA is actually losing money in the sense that the less idle it is, it's better for NASA. And so once these pictures are clipped, Mars is a huge surface, right? There's no point going around every square inch of the surface for wandering endlessly. And so to do it intelligently, what this does is it actually sends down via the satellite links the pictures that it has clicked for the last 24 hours down to the NASA's JPL laboratory or connected to us with a lease line. And their data scientists spin up a 200, 250, 300 node cluster, typically half of them made of spot instances, process these images in 2D and 3D, and then bring out information to know which are the next set of coordinates that this robot should go to, because that's where the likelihood of interesting data is. Takes anywhere between 8 to about 21 minutes, depending on the fluctuation of the frequency of the satellite, for this data to be downloaded and uploaded each way. And that's how they can do this. Takes typically 2.5 to 3 years for NASA to finish the processing every day, given the current volumes. I'm talking about terabytes per second being processed here. And after 3 or 4 hours, they kind of shut down the cluster and wait for the next set of images to come next day. Moving on, a little bit interesting, shifting gears. The Internet of Things, right, is a big thing. After the cloud and big data, the next big buzzword or the most overused term in industry today is Internet of Things. The traditional model of Internet of Things has always been this, right? This is what people are still stuck about. And this was there for many years, and this is what people are continuing to talk about, which is the intelligent fridge or the intelligent AC with an IP address, and you from a mobile phone have an app to kind of switch that on remotely and control. But today, it's actually going much beyond the fridge, right? And use cases that I really don't have time to even talk about on this presentation, which are equally interesting, if not more, over and above what I'm going to talk about. The world is expanding. Every device in some shape or form has, be it connected to a human being in some shape or form, or even not related to a human being. They all generate data. Right? It could be a sensor, it could be a motor, it could have an IP address, it could be a digital camera, and the pictures being uploaded to a social media website. All these are generating data. Right? When a baby is born, they say that the data that is generated with everyone taking a picture, sending it, and kind of exchanging it over social media website, people sending emails with pictures, everything, all the digital form kind of collected. They say is about 65 to 70 times the information that is stored in digital form. If you were to convert the US Library of Congress into digital form, 70 times that information is kind of generated potentially on an average every day, each time a baby is born. This is interesting. Unilever, their head of R&D was working with us, beg your pardon, to kind of see how they can take their innovation and their R&D to the next step. Right? And among many other initiatives, they kind of were looking at DNA sequencing. Now, the cost of sequencing of DNA has just staggeringly fallen in the last few years because of the innovation of technology and the skills. Believe the last figures we had was back in 2006, to do a sequencing of a couple of million base pairs of DNA took about $1,000, right? The cost of R&D and the processing, the IT infrastructure cost. In 2012, that fell down to about 20 cents, right? So from $1,000 to 20 cents is what the cost of sequencing DNA is, because of the volumes of gene that we're seeing worldwide. And that has led and encouraged to more and more companies to kind of continue that cycle and generate more data because the cost is so low. Unilever, for example, thought of how can we make better products which contribute to deodorants, right? And the way we can do it is study and know more about the microbes that are generated in the human body and stuck to the human body, which kind of produce the odor, which are neutralized by the deodorants. But if they can actually study those microbes better by kind of, sequencing DNA of certain human beings from different regions, depending on weather, how much you sweat, and the kind of microbes that generate, they can actually make better deodorants. And the amount of data that they ended up collecting or started to collect was scaling so much that it went way beyond the cluster nodes that they have in the data center. And they decided to do it on Amazon, and they actually run a few thousand node clusters to kind of do this processing easily in a couple of days. DropCam is another interesting use case, primarily in the US, I believe, spreading to parts of Europe, where you can actually have a DropCam instead of having a CCTV. This kind of is an extended interlink CCTV, which enables two-way communication. So you can actually, via Wi-Fi or interlink device, connect to it, see what's going in your home, keep a track of it, and have two-way communication as well if you have a kid at home. It's become so popular that they were actually constrained before moving to AWS on the amount of data that could collect, and they were actually kind of intentionally keeping it at a low scale. Once they moved to AWS, they realized that scale wasn't a problem, and then it actually saw a sudden spike. So much so that there is more data, this is their statistic, being uploaded per minute than the data being uploaded to YouTube on their site. It runs to obviously petabytes per month, that's a no-brainer. And then there are about a few billions of motion events being as of today, there are a few billion motion events that are being uploaded and stored in part of the central repository that they collect. And those are being analyzed further as well. GlowCap is this interesting concept, not related to cloud, but in general. It has an intelligent device in this box, comes in different set of pouches. What it does is, for old people, or if you were to have a weak memory, as far as taking a medicine plan is concerned, starts glowing, and if you enable, for the higher version, gives you a ringtone at a specific time of the day or week to remind you of the medicine that you're supposed to have. Further than that, if kind of the levels go down, or the threshold, it has a specific set threshold, beyond which it actually automatically SMSs or sends an email to the pharmacy saying ordering for a new pack of that. It also gives like a printed, printed report of what the patient has had and what his consumption has been, whether it's been lower than usual or higher than usual, to the doctor once every month, and that can be configured as well. This was interesting as well. The NBA in the US is doing a lot of research, I believe they're doing this in cloud, on studying the heat maps of players who score high in the basketball game. Right? So there are green I believe means high rate of scoring based on past history. Red probably means not so much. And they actually mapped out the entire court, especially on one side near the basket, as you call it, to kind of find out heat maps as well. And what they found out is, right from the shot being released to the shot being followed to a right trajectory to going in where the player scores, there are specific areas apparently where the scoring is high, and it actually busted up quite a few myths of some of the coaches there. Not only that, this actually taking it to the new level. It was taking it to a new level when they said that we kind of monitor heartbeat rates of all the players. Right? It seems they found a pattern of a certain heartbeat being in sync for certain players versus being out of sync. And they realized, and they compared data and saw that based on certain heartbeat, when there are players from a certain team who are winning, they found that the result of that was they were all in sync. Right? So the team which had more players in sync for a certain heartbeat patterns, they ended up winning more versus teams which were out of sync for whatever reasons. The player were not in sync, the passes were not right, and basically the five-member team that plays basketball, if they're not in sync with each other for certain strategies of play, no matter what strategy they follow, they kind of end up on the losing side. This is really something I would believe, if I was them, wouldn't be proud of. Ice hockey, right? If you have seen it on TV, I have a couple of times, is really an excuse for violence. I have absolutely no idea why that sport was invented. For those who don't know ice hockey or haven't seen it, by the way, officially, if a fight starts between two players because of a disagreement, the official rule is the referee can't stop the fight till it ends. It's just encouragement for just a fight to start in the field. Because kids in America have taken on this sport and they use it, and there are times when the fight gets violent as a part of the game, they have on the helmet a small intelligent device which collects data, collecting the shock of impact, so that if there is an accident or if there's a severe case of a kid or a person being severely hurt, before being admitted to the hospital, the first thing they do is take the strip out, it's detachable, give it to the doctor, attach it to a computer via a device, and that gives you a reading of the impact of that shock, how bad it is, whether there's a chance of brain hemorrhage, etc., etc. Versus waiting for the doctor to look at the patient itself. My point is, you might as well not send your kid to such a sport in the first place anyway. Ambient is doing something interesting. I'm not sure about which regions this is. They're creating longer and higher bus poles, which has a small LED screen to kind of, in real time, by taking feeds from the different buses that are running on that route, to kind of very, very accurately predict as to what is the time left for the next bus to arrive, right? What is the waiting time? And as a result, in a kind of, a landscape where the landscape is flat and people can see this pole from a little distance away. If they know that there's a few minutes left rather than waiting at the bus stop, they can actually go to the nearby shops and continue shopping and have a look outside till it reaches to about a 2-minute, 1-minute level. And they actually took data from, travelers and consumers of this app and people who travel by buses to find out that the overspending and the underspending kind of reduced and increased by a drastic amount to kind of make it level and optimal versus what it was before this whole thing. Just the last part before I end, given the scales and given a lot of these customers have run on us and we've been privileged to onboard them, what we have done is based on our customer feedback, expanded over years. We have, as of today, 11 regions, as we call them, across the world, where we have data centers. Each of these regions have multiple, what we call them, availability zones, which are multiple data centers. And a lot of customers that you saw, most of them are hosted across one of these regions. Because of the scales that we saw, some of them staggering, Amazon Web Services itself has gone into a mode where it has to rack and stack servers in the background, which you don't able to see. But a lot of customers asked us, what are your volumes, right? How do you kind of expand and what are the number of servers that you run? How do you kind of manage these volumes? Now, as a part of a secret sauce, we obviously don't disclose everything. What we decided was come up with this figure. This was last year that we came up with. I'm sure the 2014 figures will be higher, which is every 24 hours, right? AWS adds capacity to its data center. Right? We have constantly, every day, 365 days a year or 366 if it's a leap year, have hardware coming into data center. And some of it will be leaving as well if it's reached end of life. Back in 2004, Amazon.com, AWS wasn't existent then, not publicly anyway. Amazon.com was a $7 billion business. And back in the days in 2004, 10.5 years ago, we obviously had a certain server capacity in Amazon.com for running the $7 billion business. And that is the amount of capacity that we are adding every 24 hours, 365 days a year, given the scale of our customers coming in. Because it's a self-service model, there are some startups signing up with a credit card, or there are enterprises onboarding on us after meeting us. And so given that capacity, the volumes have grown significantly. And hence, every 24 hours, that's the capacity we run, which is enough to power a $7 billion business, and this happens every day. Given those volumes, where we've been lucky, we have been able to drop our pricing significantly over the last 9.5 years since launch. 46 or I think 47 times is what we have dropped pricing on our various services, and we will continue to drop pricing given that our volumes will never decrease. Hopefully, it will keep increasing, so pricing will obviously go down. Lastly, customers ask us, how much will it cost us to do something on the cloud? Run a website, run a small workload, run a CRM application, run a SharePoint application, run an ERP system. All these run on the cloud, by the way, on our cloud. And we said, okay, let's take the case of someone like a Schrodinger or someone like running an HPC or a big data workload on this. The cost to run a 100-node big data cluster or an EMR cluster as we know it is about $1 an hour. And that's how cheap it is to kind of start a big data or analytics project, which some enterprises are skeptical about given the cost of failure would be high because they don't know how to get about it. And they could run a cluster for about $8 an hour, which is the cost of a coffee and a cookie, and then shut down that cluster and things run well. Lastly, we just introduced something new. We have about 47, 48 services / products now for consumption, but we keep coming up with some services which we believe are certain pain areas which have not been solved. And so 3 years ago, we were told that, or when we were speaking to customers, we were told that RDMS or relational databases, right, were not meant to scale with the use cases that we are seeing with the social media websites today or the mobile services, right? And that's why NoSQL databases have come into the picture. But there are certain use cases where you still require a relational database service, which is where we launched something called as Amazon Aurora. We were working on this project secretly for the last 3 years. November 12th is when we launched and announced this, which is simply a MySQL equivalent database, similar to MySQL, based on the MySQL engine, but our own custom kind of code written on top of it. The scale is literally 5x, given the same amount of CPU and memory to serve any workload. And it's going to be cheaper as well. This was just a launch announcement. January is where we're looking at, the beta to be out, and February is when the general release will be out as well. With that said, I think that's it from me. Those are my connects. Happy to connect offline after this as well. That's my Twitter ID. I believe we have time for a couple of questions. Happy to take them now, if there are any. Yes, sir.
Why India doesn't have region?
Good question. I keep getting asked the whole time. So 2 things. One is, we as a policy do not pre-disclose dates for regions. If you have seen our history, we have grown from, I think, 3 regions back in 2011 to, 4 regions in 2011 to 11 regions today. If you have heard Jay Bezos' comment when he met Narendra Modi back in September when he was in India, I had the pleasure of meeting him for 15 15 seconds. He mentioned to him that we are looking at opening data centers in India. So it is a matter of time. We are speaking to our current customers and our prospects to ask them what they require in data centers and what the impact of the data center will be. Obviously, there are some workloads like compliance related, which are banking sector, FSI, BFSI, telco and others, which require region India. There are many others which don't come involved in that compliance. So we are evaluating option. It's just a matter of time. Fair question. Time for another question.
Questions? Yeah, right behind you.
Yes, sir.
What is Amazon's take on open source and your contribution to open source?
Yeah, great question. So a lot of it I don't have visibility to because a lot of that happens in Seattle. We do consume and work with the open source community a lot. Our base hypervisor on which our virtualization platform runs is the open source Zen hypervisor. And that has been customized to a significant extent. And to ensure that it is secure, because security has to be our number one priority given the hundreds and thousands of customers we have to work with the open source community. So we do consume and contribute a lot to open source. And as a result of that, we could afford the price points that we have.
Thank you. Next question is down here, please.
Shantanu, great talk by the way. My question is regarding Aurora. In the time and age of NoSQL databases and key value stores and and more applications that depending on real-time data stats, why would you spend 3 years on building something totally based on RDBMS?
Great question. That's the question I had too. We do have a NoSQL store of our own called DynamoDB, right? For customers who don't want to run their open source NoSQL stores on Amazon, want to use Amazon's NoSQL store, we are fine with that as well. What we realize is when we went to customers, legacy applications which are slowly being transitioned off, but there are these thousands of organizations, SMBs and enterprise above, who will not have use cases which are compliant with NoSQL key value stores. They will have a relational need for some of the use cases because they are simply built on those use cases 30, 40 years ago. And that's not going to go away overnight. We still see for the next 4 to 5 to 8 to 10 years, the relational database is here to stay. A lot of it will be taken away NoSQL, you are absolutely right, but that's for the new age companies. You still have those large legacy enterprise applications which are going to stay. And the ecosystem, it's not just companies, it's the ecosystem of technology partners, let's say Oracle, Microsoft, etc., who aren't going to change overnight, right? It is kind of a journey there. So for the next 5 to 7 years, relational databases will still have a big.
Thanks.
Next question's up here, the gentleman in the striped shirt.
Hello, sir. As you say that you are having 13 data centers, I see that there are no data centers in the African and the Indian region. So how do you serve the customers there? I mean, do you have any edge or CDN services?
We do have edge CDN services. So similar to the other gentleman's question, we have edge locations in India, in Mumbai and Chennai. We do have edge locations in Eastern Europe, Western Europe, where Africa is kind of close to there in terms of latency. In terms of content that can't be served via caching or edge locations, customers in India, most of them use the Singapore region. Singapore to India, what we've seen is with the recent kind of ISP peering center from Mumbai and Chennai at least, it's about 65 to 75 milliseconds round trip. And most customers are happy with that, at least with the application that they are hosting. But we do have edge locations on top of that in Mumbai and Chennai.
Thanks.
Time for one last question.
Yeah, one last question. There's one over here. There's one there.
Yeah, okay.
It was a great insight, thank you. I just have a question, a small suggestion basically. We are a developer and we heavily use your service, Amazon services. And the problem what we face is, whenever we are uploading something, we are not sure whether it's going to reach the destination. So we generally have to do a lot more back and forth. So there should be some facility where we can see where the data has been reached. That would be a great tool for us.
Yeah, let's connect offline. There is a way you can do that with our APIs, but let's connect offline. Right, that said, I think we're just out of time.
We are just about out of time. So actually, we have a minute left. So if you don't mind, we
the
can.
gentleman there.
Yeah, he was.
Hello, sir. Kindle is a great product of this Amazon.
Yeah.
This is not accessible to visually impaired, especially Indian languages. We have launched Amazon.in in India. So is there any planning to make available application which supports Indian language, especially to visually impaired who read books with the help of screen reader like JAWS and NVDA?
Yeah, great question and great feedback suggestion.
Yeah, please do it for us so we can read these Indian languages. Because Kindle is very great product, I believe.
Yeah, great suggestion, great feedback. Not something I thought of personally, but a great suggestion. It's an obvious one. I should maybe feedback to the Kindle team. That's not a team that I work with, but I know folks from that team in India and US who will be more than happy to take this as feedback.
All right, thank you so much. Shantanu, please join me in thanking Shantanu for that amazing